Alright, in this video for 5.1, we are going to build the polynomial function given parts of our graph. So in this case, we're looking for a polynomial function with the following zeros: x equals 1, -1, and 5, and we have to have a third degree function. So that means we are looking at x to the third as your leading term. So what we do is we take all your zeros, we set them equal to x. And what we're going to do is we're going to kind of build the polynomial by solving backwards. So we have our x-intercepts, we turn those back into binomials by setting them equal to 0. So I subtract over the 1, add over the 1, subtract over the 5. Take these three binomials and we're going to multiply them together. Now when we do our first foiling process here, I'm going to go with this first one, these first two here, because this is what we call a conjugate pair. You can see that if you FOIL this out, you're going to get a positive 1x and a negative 1x in the middle, and they'll cancel each other out. So this is going to be x squared minus 1. Now FOIL these two binomials together. You'll get x squared times x is x cubed. X squared times a minus 5 is minus 5x squared. Negative 1 times x is minus x. Negative 1 times negative 5 is positive 5. Here's your polynomial function. You can now drop the 0, if you will, and set it equal to f of x. Our second example has a little bit of a twist to it. So this is not in your notes, so please add this next sentence to this problem. When the author changed additions, he started to tweak some of the homework questions, so I thought I'll tweak one of my examples to fit some of his homework. So here we have a polynomial function of 0, x equals 0 with a multiplicity of 3, and x equals 1 with a multiplicity of 2. So this will have a degree of 5, but this function also contains the point 2 comma negative 16. So we'll do this problem just like we did before. Take all your zeros, set them equal to x, and we're going to build our x to the fifth as our leading term for our function here. Now what happens here is that because x equals 0 had a multiplicity of 3, that means this 3 is the power on that x. And with x minus 1 having a multiplicity of 2, we're going to put that 2 as the power on this binomial and then multiply the x cubed and the x minus 1 squared. We'll multiply those together. So FOILing out this binomial gives me x squared minus 2x plus 1. Then distributing the x cubed, that gives me x to the fifth minus 2x to the fourth plus x cubed equal to 0. And this is my proposed function right now, x to the fifth minus 2x to the fourth plus x cubed. To make sure this is correct, we have to go back to this point that was given. We got to make sure this is true. So we have to show in function notation that f of 2 is equal to negative 16. That's our point. So I'll take the 2 and we're going to plug it into our function here. So 2 to the fifth, that's 32, minus 2 to the fourth is 16. 16 times 2 is 32. And 2 to the third is 8, so these 32's cancel out, leaving me an 8. So the point that I have with the function that I've built so far is 2, 8. So this, if you will, is not my function. There's something missing. How do we get to negative 16? Well, when this happens, this means that there must have been a numerical factor, a, that's usually that leading coefficient in front of our x to the fifth, that was not multiplied during the FOILing process. So over here, there must have been a number multiplied to this x cubed that had to be distributed to get to this negative 16 that they want. So to find that factor of a, you divide the desired y coordinate, which is negative 16, and you divide that by the existing y coordinate that we have found, 8. So negative 16 divided by 8 is negative 2. So negative 2 has to be multiplied to the entire function. So there must have been a negative 2 here. Well, of course, if you put negative 2x cubed and you solve that for x, 0 divided by negative 2 is still 0. You lose it. So negative 2 gets multiplied to all three of my terms, and that's my new f of x. So now if you take your 2 and you plug it into all your x's, you will get that 8 multiplied by a negative 2, which now gives you the negative 16.